Hello student, the question says an ideal resistance R, ideal inductance L, ideal capacitance C, and AC voltmeters V1, V2, V3, and V4 are connected to an AC source as shown at resonance. So basically, we need to comment at resonance which voltages will be equal. Now, if you look at this diagram, so let us look at how the current actually flows. The current flows in this direction. No current flows through these voltmeters. We'll assume these are ideal voltmeters with infinite resistance. So current only flows through these resistors and then inductors and then these capacitors. And this is how the current flows in the circuit. Once you understood, then what is this V1, V2, V3, V4? They are just given to represent the voltage measured in the respective one. He has used the word called resonance. What is the condition for resonance? Let me just explain a little bit. In AC, there is something called react impedance. We indicate with Z, and the formula for impedance would be root of R square plus XL or XC minus XL whole square, where XC is basically capacitive reactance and it would be equals to 1 by omega C, and the XL is inductive reactance and it is equals to omega L. Now at resonance, if I take at resonance, this Z must be equal to R. So if Z is equals to R, when can this expression suddenly become Z is equals to R? So it indirectly implies that XC and XL are cancelling each other. If XC and XL will cancel each other, then Z would be equal to R. There is another advantage when Z is equals to R. The current in the circuit would be maximum. So remember this, at resonance, XC would exactly balance XL and we get Z equals to R and the current in the circuit would be maximum. Okay. Now, since the author has given resonance, so indirectly is telling XC is equals to XL. We know the same current flows in all of them. Since same current flows in all of them, if I find what is V1, V1 would be simply I into R. If I find what is the value of V2, again it is I into, we don't say R here, we have to tell XL. Similarly, if you find what is V3, it is I into EXC. Then what about the V source? V source would be equals to root of V resistance square plus V capacitance minus V inductance whole square. So this will be the formula here. Since this is the formula that we have, so we have V1 equals to IR. So let us make some conclusions from this. We got V1 equals to IR, V2 equals to IXL, V3 is IXC. Since IXC is equals to XL, we can directly tell V2 equals to V3. So I'll just take it to the next page. From this, we can directly conclude that V2 is equals to V3. Not only that, we know V source square is equals to V1 square plus V2 minus V3 whole square, or V3 minus V2 whole square, anything is fine. Since V2 is equals to V3, we can even tell that V source would be equal to V1. So based on that logic, who is representing the total voltage? Total voltage is represented by V4. So the final conclusions from this is that V4 is equals to V1, and at resonance both of them would have same voltage across the inductor, voltage across the capacitor would be same. So we can even say V2 is equals to V3. So V2 equals to V3. The option is that reading in V2 is equals to V3. This is correct. He's telling V3 is equals to V1. That is wrong. It is possible, but it is wrong. Reading in V1 is equals to reading in V2. This is also possible. Now you might wonder, when is this possible? If this XL is also exactly equal to R, this XC is also exactly equal to R, this R minus R also would cancel. So that's why this is also a possibility. But he's saying every time it is possible, so it is wrong. Next, reading in V2 is equals to reading in V4. Wrong. Reading in V1 is equals to reading in V4. So this is also wrong. So the only correct answer for this would be option D. Hope you understood how I have solved. Remember this. What is the condition for resonance? Just rewatch it again. And how we have concluded V source is equals to V1 and how we have concluded V2 equals to V3. Hope you understood how I have solved. Thank you.